Okay, this is an experiment. One of the things students have said to me a number of times is that it would be really helpful to have a lecture that they can actually listen to the stuff as opposed to just reading it or have other ways of having the information presented. So I'm going to try and do a series of short lectures on each chapter as we go through this semester during the summer. See how it goes. I've not done this before. I've always done much more structured sorts of things using PowerPoint or those sorts of things or the videos. This lecture should not include any material that's not particularly already in the chapter someplace. I'm not going to try to introduce new concepts this way, but I want to just get a chance to talk about them a little bit more and have that sort of presentation. Um, Let me talk to you about the nature of statistics and particularly what I think about what statistics is first. Again, statistics is a science of conducting studies to collect, organize, summarize, analyze, present, and draw conclusions from data. And this is the important part in order to assist us in solving problems and making decisions. Um, I'm going to talk in this later in the course about sort of how statistics is the foundation for a lot of knowledge, how you know things about in the real world. But this for me is more at a this is broader than that. This is a way of sort of how do you get information to make decisions or to solve problems, and that's going to be a big part of what this course is going to be about. Um, I also note there's very little in here about there's nothing here, in fact, about computation. Computation for me is a relatively small part of this field. A lot of us trying to think about how do you pull the information together and how do you organize it and how do you summarize it and then analyze it, and then here's a couple big ones. How do you present it to other people and help them draw conclusions or draw conclusions from it? That's a big deal. The first thing to start with here is, again, many students when they get into this course are a little surprised with this chapter because they're ready to get they're ready to get into statistics, but they're a little hesitant about getting into statistics. And they want to say, well, can't we just get on with it? And the reason you can't get on with it is because I'm going to present some concepts this first chapter that end up being reflected again and again through every chapter in the almost every chapter in the course. The basic concepts are really important, and I'll come back to them a number of times here. The first thing is about the nature of data. Statistics deals with large quantities of data. That's a strength. If you're going to talk about how often my cat eats, it's happening right, wandering up against my legs right now. That's a relatively small, from her perspective, a very small set of data. She thinks it should be much more common than that. But the power of statistics is you can look at huge amounts of data and try and make sense out of it, finding patterns within the data to help you draw better conclusions or solve problems. And that's really what I want to think about is what's the nature of data itself? Or just note, I heard something recently that I really loved this statement. I also teach abnormal psychology, and I not too long ago had a student in one of my classes that I would talk about something and say, oh, but look at the psychiatrist who ripped off his clients this way. And I'd go, yeah. Well, her point would be, show psychiatrists can't be trusted. And I'd go, you have an incident, you have an anecdote about somebody who did something. Now, I don't deny there may be others, but you have got one instance here. That doesn't prove anything to me at all. And then she'd come up with the second one, and then she'd go on YouTube and find 3 of them. And I'm still going to go on, do you know how many psychiatrists there are in this country? And just in this country, talking about what 3 of them do, that she found something about something 3 of them did, is a really small sample. And the line that somebody used recently says, the plural of anecdotes is not data. Data is something that's broader and is more systematically collected in a way that helps you make some sense of it. 2 major kinds of data. There's qualitative data and there's quantitative data. Quantitative data is numeric. It's a measurement of something. It's a way of putting it's information that's in numeric form. Qualitative data is in some different form. And it's not that it's bad, it's just that you can't do much analysis with a large amount of qualitative data. I would note for you, for instance, we did a number of years ago, I analyzed some survey data from a program I worked with community college. And we'd ask them things like, how many credits did you have when you took this course? And people would give me a number. It's like, that's quantitative. The number of credits you have earned and so far in your career, it's a piece of quantitative data. And then the person who constructed, it wasn't me who constructed this questionnaire, said, how did this program, it was the assessment of prior learning program, how did this program impact your obtaining a college degree? Well, people wrote paragraphs about that in some cases. And it was really interesting information. It told me a lot, but it's like I ended up going, it's all qualitative data. What do you do with that? And there's again, that's where we're going. It's like there are ways of turning that qualitative data into quantitative data. But there's limitations to it. And that's what this first chapter is all about, is what data looks like. Within quantitative data, there are four major kinds of data. The first one we call nominal data. Nominal, it's a name. It's a number in name only. The premier example of this is a zip code. I have a zip code where I live. It's a number. You can't add zip codes up. You can't subtract zip codes from each other. You can't find an average zip code. It's like zip codes, you can count the number of zip codes you have. And we could, in fact, take the zip codes from every person in this class and create a graph with them and find out how many were in each zip code around the state. But you can count things and you can figure out proportions with nominal data, but you can't do anything beyond that. Nominal data has very limited usefulness. There are some ways it is, and I'll try and tell you more about that as we go on. But nominal data is a specific kind of data that's a data in name only. The special case of quantitative data, of nominal data, is what's called dichotomous data. That's where there's a yes and a no, and you make the yes 1 and no 0. You put a number on it, but it's basically there's only two choices or something. You have forced choice, go this way or go this way. No of those two choices out there. That's a very special kind, and there are lots of special cases of things you can do with dichotomous data, as opposed to multivariate data that has data that can have lots of multiple values to it. So the first type is nominal. It's data in name only. The second kind of data is ordinal. Ordinal data tells you the order of things. That's fairly straightforward. It's like first, second, third, fourth, fifth. It tells you something more than nominal data. When I say my zip code is 05672 and yours is 05677, which one of us comes first? And it's like, the question doesn't make any sense. Comes first on what? It doesn't help you any. But if I said, I live in the largest county in the state, I don't actually. There's like your largest and your next largest, and you could order that data. There's a little bit more information with ordinal data than there is with nominal data. Not a lot. It's still fairly limited what you can do with ordinal data. One of the things about ordinal data is you don't know how far apart things are. I can know that 4 racers finished first, second, third, and fourth. I don't know whether the distance between the first and second racers was this much, or whether it was much bigger. I mean, I have no idea. And I don't know whether the same thing is true between second and third, or third or fourth. I don't know how far the racers between the racers there are when they finish first, second, third, and fourth. I only know the order they finish in. Very limited stuff you can do with ordinal data, but there are some things. Then becomes the most useful kind. Well, there's two of them actually, but the most next level up of this thing is called integral data, interval data. It talks about the intervals between numbers are exactly the same. The distance between first and second is exactly between the distance between second and third and fourth. So the distance between numbers is always exactly the same. The interval is constant between them. Nominal data, there's no interval between them. Interval data, you don't know what the, nominal data, there's no distance between the numbers. Ordinal data, you know the order of it. Interval data, you know how much space is between numbers. Then there's a fourth kind, which is ratio data. The thing about ratio data is ratio data has a real 0 point to it. And that gets a more complex thing. But for the most part, interval data and ratio data, you can treat them as one thing. They're not exactly the same thing, but close enough in most cases. Now, one of the other things, and let's share my screen here again. Another kind of way to think about data is it's either discrete or it's continuous. I can have 1, 2, 3, or 4 as 4 numbers on something and have them so there's no space between them. There's either a 1 or there's a 2. There's nothing between the 1 or the 2. You think about discrete data, for instance, is how many children do you have? You might have no kids. You might have 1 child. You might have 2. You might have 3. You might have, but you don't have 2.4 kids. You don't have, no one says, I've got 3.2 children. You have a discrete, there's always discrete numbers. There's nothing between them. On the other hand, you have the continuous data, which is this lower line down here. And again, the intervals between the things are exactly the same. But the other thing without discrete data is that what you can do is I can't change around here. You can find a place between any 2 numbers on here. Between 2 and 3, there are literally an infinite number of possibilities between it. Now, the limit on that tends to be, what's the limit on how well we can measure, the precision of our measurements. But theoretically, there's an infinite number of spaces between a 2 and a 3, as there is between 3 and 4, but the distance is exactly the same. Now, this will become important later because we're going to talk about things particularly like frequency distributions and probability distributions. You can have a discrete probability distribution where there are only 4 choices and you say what the probability of each of those 4 things is. Or you can have a continuous distribution where you could have a 2.5 or a 3.3 or 3.4 or 3.7 as a value potentially. And it makes the distributions look very different and the mathematics of it becomes very different. So they use different formulas for it. I would note for you, when I did the survey data with where I work for community college, I looked at the question of how did this program impact your college degree? And what happened with that is the students, as I read through, I think I did between 80 and 90 surveys. As I read through the surveys, I read them through and I went back and I read them through a second time. And, and by the third time I read it, I went, there's some categories here. And I started going, one group of students said, the respondents to my survey said, I couldn't have gotten my degree without this program. This is the assessment parallel program. It was necessary. It was essential for me getting my college degree. A second group of students said, I probably would have gotten my college degree anyway, but boy, this sure helped. And this made it so much, this kind of year off my career, the schooling or something. But they said, basically, I would have done it anyway, but this made a serious difference for me. A third group of students said, it didn't make any difference at all for me. It made no impact on how I did how fast I got my degree. The fourth group of students said, the dog ate my homework. And I went, huh? There were, and it wasn't quite that with language, but as I read over student responses to how did this impact how this program impact your ability to get your college degree, I got answers like, well, my mother told me to do it. And I went, huh? That your answer doesn't respond to the question. But I could take 80 to 90 responses and put them in one of those 4 categories. Then what I could do is I could sort them by those things. That was one thing I could do. I could sort by them. The second thing I could do was I could find the proportion of each one of these. The dog ate my homework. It was like less than 5% of the students said that the responses were that kind of non-responsive answer. Or it didn't make any difference to me whatsoever. It's been a while for me to remember this, but I would say it was like 15% of the students said didn't make any difference for me whatsoever. So well over half, probably 75, 80% of the students said couldn't have done it without it. I could have done it without it, but it really made a difference for me. So that's a way of taking qualitative data, transforming it into nominal data, and then doing some computations or sorting by the use of those things. And that's somewhat how those things can be done. There are lots of ways to manipulate data, or manipulate is not the right word, it's to organize data. For instance, if I took that data, I could sort all of my responses by those 4 things. And then I could look at the students who said, I couldn't have done it without this, and say, how many credits did they have on average for that group when they started the program? I can look at that for the other things. I can compare the groups based off that criteria for things, which gave me a different way to sort or make sense out of the data, saying, how are these students different compared to what kind of difference it made for them in the outcome? What made a difference? Why, for some people, it made all the difference in the world, and for other people, it made no difference. And then that 5% whose dog ate their homework, those I couldn't make sense of at all. So that's a brief piece about data and how I think about data in this process. Let me just mention one other thing from the first chapter that I think is important, but I'm not going to go into it much. And that's the issue of sampling. Statistics has a lot of sampling. That is, out of a large population, we take a smaller sample of people. I want to be able to generalize to how people in Vermont think. Well, there are 625,000 people in Vermont. My bet is, my experience is, they think a lot of different ways in this process. But how small a group can I choose to get a good representational sample of those 625,000 people? And you might be surprised how small that number can be. If it's done randomly, the selection process must be randomly done. And there are all sorts of ways that we can lose randomness, or we get data that is not fully representational of what happened. In the chapter, I write a thing about, I tell a story of how they looked at airplanes during World War I, back when they had 2 winged airplanes. And they tried to look at the pattern of how gunshot holes on the airplane to tell you what part of the airplanes might be better armored. The problem with it is they had, so this percent was on the engine area, this percent was on the body of it, this percent was on the wings of it, this percent was on the tail of the airplane, whatever those things were. And they asked a statistician about it, and he said, there's a problem here. You're getting back information on the airplanes that came back. You don't have any information about what parts of the airplanes that crashed, where the bullet holes were on that one. And you might suspect that if the bullet holes is on the engine, the plane would be much more likely to crash. And those that came back, where the bullet holes were on the engine part of the airplane, would tend to have less serious damage to the engine. But we don't know, because the sample that we have, those planes that come back, was not a representative sample. Now I gotta tell you, the whole area of sampling is a serious field of study all by itself. There are people who make careers out of working in sampling and how to get good representative samples. I would just say couple things about it. One of the things that we tend to use in this field is some stuff that's called, I'm blanking on the word right now. It's part of the problem being 70-some years old. Thoughts are there and they're gone. It'll come to me a bit here.